All right, so this is, where's my clicker? How does this work? It's not the way I normally like to start a seminar. This is about the crazy things we've learned, and I have a question for you. How much have you thought about why your parachute flies the way it does? Like, why? The aerodynamicist or the instructor would give you these very concrete terms as to how all this stuff works, usually a very technical understanding. That's certainly not all of it. There are two other parts. I'm going to talk about the second part, which is test jumping in this seminar. The third part, I'll just mention at the very end. So basically, this is a glimpse behind the scenes at Performance Designs in the testing department. Now, actually, we have a separate company that does our testing. It's basically PD employees that work for this separate company, and the reason is because we care about our test jumpers. I care about myself because I do it as well. We want them to be protected by a company that's designed for that risk and for that job. And we actually do testing for other companies because other companies have asked us to. This is like a little snapshot of some of the stuff that's happened in the last 35 years. And I'm also going to look a little bit about what came before us. So it's not a technical seminar. It's primarily for entertainment. Kind of imagine that we're sitting in the bar and we've lifted a few drinks, and this is where the stories get a little wild, okay? Not just yet, but we'll get there, all right? So your cell phones are silenced and everything. Let's get going. The first thing I want to do is to cover our general approach to R&D. Basically, we start with our design goals. What do we want the parachute to do? We don't say we want an aspect ratio of 2.71 and 9 cells with cross braces and this kind of line. That's how we do it, but we want to know what we want to do first. The parachute's supposed to fly in a certain way. It's supposed to open and land in a certain way. It's for a certain set of skills, a certain type of result. Then we basically design a first prototype using our experience from the past. And we jump it, and we see what it does. Normally, it's not so good. Sometimes it's good, but it usually has some ugly stuff. So then the question is what do we do? And basically, we discuss it. We modify it, if we can modify it, to try some other idea. Sometimes the idea requires a new parachute, and we build one, and we jump that. We don't do a bunch of dummy drops or anything to prove that it's good. What is it going to prove us? It's a dummy, so we jump it. We do that a lot. We've built over 2,000 prototypes. That's more than some parachute companies have sold. And we've made many, many iterations. It's approaching 10,000 iterations. It says 45,000 test jumps since about 1994 when we decided we needed a company logbook. That slide is 2 years old. It's actually closer to 50,000 now. This does not include testing for materials. When we have a vendor who wants to sell us a new material or wants to create one with us in collaboration, and we have a material that meets our specifications, our desires, it does so when it comes off the roll. How will it wear? Our test jumpers are valuable resources, and they're doing a very challenging job, and we really don't have the time or the budget, for that matter, to put hundreds and thousands of jumps on a single prototype. So we actually enlist the help of some of the teams that we have that are sponsored, and full disclosure, we let them know that we'd like them to help with seeing how the material ages. And so somebody that might make 1,100 jumps a year will jump that parachute and send it back to us every 100 jumps. We'll look at it, measure the characteristics of the fabric, we'll jump it, compare it to a control sample that hasn't been jumped. And we'll keep doing that until the parachute has reached its life limit. And we really appreciate them doing that because it allows us to do the test jumping that's a little scarier, a little more creative. So onto the main subject area, test jumping. the test jumping at PD is a little unique from a lot of people. We're going to talk about the challenges of test jumping and also some unusual testing. I can show you the normal test jumps, and sometimes they look like a normal jump. They sometimes are kind of boring. Sometimes they're a bit too exciting, but normally they're pretty normal. But I wanted to show you some unusual stuff that we've done over the years. And I want to try to show how this relates to the evolution of skydiving as well as just the parachutes. So first we have to pay respect for the fact that we didn't invent parachutes, and we weren't the first test jumpers. Obviously, somebody lobbed themselves off of a mountain or a tower way, way back when, and it's been happening since well before all of us were born. This gentleman here, Joe Kittinger, was a military Air Force career guy, and they were looking to develop pressure suits for astronauts and high altitude flying. And they wanted to go really high, and he said, I'll do it. Maybe he missed that part of the training not to volunteer, but he eventually jumped from a balloon from 102,000 feet. This was 1960. That was the year before I was born. And that's amazing, and I've met the guy. He's really humble. There was a lot of information that was gained from those jumps. And when you look at pressure suits nowadays, they're usually certified to 100,000 feet because he went to 102. And I actually got a chance to meet him. That record stood for 50 years, and then Felix Baumgartner beat it. And then another gentleman, can't believe I'm spacing his name right now, but he went beyond that. Excuse me? There you go, yeah, thank you. I know him well, I'm up here staring with a blank head right now. They're all great people, and they did really cool stuff. And Joe Kittinger is a real gentleman. One thing he was not then was an experienced skydiver, certainly not, and he was also not an experienced parachutist. That jump from 102,000 feet, I think, was his 24th jump. Okay? It really makes me wonder what these guys are made of. The people that are like my heroes, the people that I admire and want to be like. I'm certainly no Joe Kittinger, but I've had some interesting experiences. We'll start with some questions about the stuff that I was jumping as a student. I started in '77. That parachute on the left is a C9, and they called it a modified one. And my course was a week long for my first jump course. And we actually had some time to talk about the history of parachutes and parachuting and things like stability and how it came to be. And they told me that this parachute, which was called a 7TU, it was modified so that it had an amazing 3 to 5 mile an hour forward speed. And the wind limits for students were 10 miles an hour, so we did a lot of that backing up on landing. But literally what people did was they got tired of drifting completely with the wind, and they just took scissors and started cutting holes in the back of the parachute because they had an idea that maybe some air would leak out and push it forward. There was also a 9TU, and the young guy that jumped that was a little bolder than smart, and he broke himself up. So everybody backed up one step, and it was a 7TU. The 7TU refers to the shape of the hole. When I first gave a seminar about this old stuff, a friend of mine, long since passed away now, he screamed in the back, you can't jump one of those as a student because you had to have 200 jumps before they let me, I had to have 200 jumps before they let me jump that 7TU. So obviously there's even stuff before that. The point is my question is who did that? And they were test jumpers. Did they know they were test jumpers? It's part of the evolution of the sport. The one on the right side here, that's a paracommander. That was my first parachute that I actually owned because my mom was tired of people taking the club gear and stealing it. We'd put our name on the tag when we packed it. We packed all of our chutes from the first jump. That thing had 27 holes in it and the craziest steering system with the toggles on the front risers. And I actually met the man that invented that thing, and that stuff is really amazing. The willingness to leap out of an airplane with that stuff is, to me, it's impressive, and it still is to this day. So it goes on to other stuff. Since then, oops, yeah, that was before my time. That's called the sail wing. I've met a few people who have jumped those, some of whom jumped the very first prototypes. They had a very, very flat glide and a fast glide when nothing glided. They had no flare. They were not that reliable. That's why parachutes don't look like this. But it took a lot of talent to even get a single surface parachute like this to stay open. That's to me, a lost art. I don't know anything about single surface. The parawing, kind of like a Regalo hang glider, and this thing over here called a volplane, that looks like a ram air parachute, but only the front part is inflated like a modern parachute. The back part is a single surface. That also is a little unusual. It had a hydraulic reefing system. There's actually a gentleman by the name of Jim Wilson who visits us every once in a while. He's really into these antique parachutes, and he has one. So I actually saw this hydraulic reefing system, and it's like a little thing with hydraulic oil in it, and at a certain point, this spring and this plunger kind of goes through this bunch of oil, and then when it finally gets to the end, it flings things open, and then lines go everywhere, and the parachute opens. And you had to adjust the viscosity of the oil when it was cold compared to when it was hot, and it still knocked you crazy when it first opened. He actually jumps that stuff now. I'll pass. So the point is that these things are very unique. They were ideas that were tried and at some point discarded and sometimes picked back up again. This is a parasled. It's very flat. It's got a split in the middle, and the whole tail does like ailerons. It was designed by a bunch of NASA scientists. Still no slider. It was actually 0P. 0P. It had valves in the leading edge that would close up. Very interesting parachute. Sometimes it didn't stay open. Because of the flatness of it, when the thing inflates, it wants to have a compressive thing on it, and if the center cell compresses, then the wing gets at an angle, and then it basically flew into one another. The point is that somebody came up with these ideas and actually jumped them. I cannot tell you what that is. I was searching on the internet for some pictures of this old stuff, and I went, what in God's name is that thing? And I can't begin to describe that, but it's all part of the evolution, okay? And it never would have happened without the people willing to jump them. That's my first rig. It's Bill Booth's fifth Wonder Hog, fifth hand-deployed rig. It was not TSO'd. I had no idea what a TSO was. When I got out of college, I jumped in high school, and this is in college. And that's my baby paraplane that was modified. Did I skip a picture? The one on the left is a paraplane, one of the first rammers on the market. It has long lines because that's what round parachute lines look like, and flew kind of weird, and nobody could land them. So one day they got the great idea, let's make it 30 square feet larger. Well, when we got to this one, we thought it was a paraplane, and we got a line set that would fit it, a Stratocloud line set. And then when they put the stabilizers on, which was quite an innovation, they were about 1 meter too long. And they went, oh, we'll just cut them down. And my rigger was God, so I thought, and it was a collection of parts that weren't supposed to go together. So that parachute was very different, but it got me through college. I had no idea I was a test jumper. I was just following the advice of my rigger, bless his heart. I met a man in college on the left. His name is Bill Coe. He was the founder of Performance Designs, and I jumped a couple of his parachutes at the end of college, and it just tripped my trigger, man. I was just like, oh my God, this is amazing. And he said he had a factory, Performance Designs, and I assumed he had some big factory with hundreds of people there. I eventually noticed that he had 6 sewing machines in a bedroom, basically. But anyway, it was enough for me to go crazy, and I went through what I would call my postgraduate studies, which basically means I moved into my van and lived at the drop zone. And I packed parachutes and did tandems back in the early days of tandems. That's a Hornet in the middle, the old school Hornet, kind of like Bill Booth told me during this time I was at a party at his house in DeLand, and I asked him about the future, and he said that the future of skydiving equipment was pretty much nothing much different, because he'd made the rig that had the main and reserve on the back, a cutaway that eliminates entanglements, a single point cutaway, hand deployed pilot chute, free bag, all that stuff. And he said the parachutes were as small as they were going to get in terms of pack volume, because you can't make fabric any smaller or remove any more reinforcing. And everybody knows that if you have a parachute smaller than 200 square feet, it's just going to land you hard. So we're done. And like 6 months later, after playing with the parachutes with Bill Coe, I was jumping this 150 that you see on the left. And I think I'm barefoot because I was, whatever, silly or full of freedom living in my van. So as time went on, we started playing with different aerodynamic design changes that we were told wouldn't really make a difference. It's just a drag device that slides forward. And I kept noticing as the parachutes would fly very different with the most minutest change in the design. We were just cutting and hacking on fabric. We didn't know any better. And I kept noticing that there was something that aerodynamically I thought was a tip stall. I'd come into land, and then right at the very end, like a tip would drop off. Airplanes do that sometimes. And then I saw this picture. I went, is that really the parachute? As you can see, my right toggle is very, very down low, and that may not seem like a revelation to you guys, but in 1984, it was a revelation to me that it was me and not the parachute, which began this whole idea of what a test jumper really is in my mind. The question is was it me, meaning my technique, or was it the parachute, which means my parachute design? Either way, I was kind of screwed. Had to figure out something. So in any case, it was a fun time. We played with all kinds of stuff. It wasn't too long before we were in Miami, and I was jumping. That was actually the second cross brace canopy. It actually has external cross braces. It's the way to keep the canopy flat, but it was lines that were spanwise cascaded onto every rib. That one's 110 square feet. At the time, I still thought I was indestructible. Probably had 300 jumps. This thing on the bottom is a tri-cell paraglider that's actually built in the UK. It's called a Harley chute. And if you look at the cells here, the center chamber of each cell lifts upwards. And that other parachute that I showed you up here was built just like that, and it kind of arched between each cell, and it looked like an accordion when I'd flare it. So I stuck the other lines on it to hold it flat. And I had Bill Coe jump it, and he said that was really cool, and it's going really fast, but we need to get that drag out of there. So let's put that inside the parachute in the form of diagonal ribs. And that created the cross brace. And that's I believe, the second cross brace canopy we ever built. We patented it and eventually put it on the market as the Excalibur. Things were pretty quick in those days because we were so addicted to the things we were discovering. We were a little naive as to the practicality of those parachutes. When people were excited about them, we let them get one. From 260 to the first 120 square foot. This one is a video. I don't know if I could start it. Is there any way? Can you start this video, please? This is an Excalibur paraglider. It's crazy long and skinny. It's still rectangular. It's got a 4.6 to 1 glide ratio. That's an hour and 40-minute flight. I think that was my third paraglider flight. I ended up crashing into the hill because I spun it around, got a little too slow in a turn. But that was actually the first cross-braced paraglider. People called them Excala dogs, if they can remember back that far. The reason why it was successful was because it was very stable and you could fly in crappy weather. We got out of that shortly after that, but we sold quite a few of those. So now let's speak about the actual test jumping. So that's usually the way people see it as they entertain the idea, or if the opportunity comes up to them. They want to do epic shit. And you feel like that at some point. Sometimes, several times you feel like that. The people around you who are doing test jumping are patient with that phase because they know that eventually you'll realize that you kind of look like an idiot. Sometimes. So there are challenges with being a test jumper, and they're mostly mental, like most problems in the sport. First off, great jumpers don't necessarily make great test jumpers, just like they don't make necessarily good instructors. It's a unique set of talents. Sometimes they're overconfident. They think they're indestructible. I've had that phase several times. They may lack confidence to the point that it's a danger to them. There's a balance somewhere. They may have lots of experience, but very little experience on a variety of parachutes. If somebody's got 7,000 jumps on their Stiletto 120 and they jump anything else, it's a bit of a tough transition. Sometimes they do jump different parachutes, but they do it the same way every time. They need to experiment with a variety of techniques. The most common situation in that regard is somebody that always does a high performance turning approach on front risers, and then he's at a loss at some point when he has to do a straight in into a tight area. He may not have done that for thousands of jumps. The biggest problem is the unwillingness to challenge your mindset about what a parachute is, how they fly, what the laws of aerodynamics say, what can and can't be done. These are things that we don't normally question. I've had jumpers say, well, of course I didn't get it into level flight because I'm not loading it up enough. Somebody that might weigh 50 kilograms or something, not being able to get a 170 into level flight, and it's like it's a technique problem, if the parachute is a reasonable one. This is one that I lose a lot of sleep over. At some point, the test jumpers start to really get an idea of what we're doing, and they have absolute faith in the designer, which is usually me. And it scares me because we try the smallest, tiniest changes that we think will produce a better result, and sometimes it produces a terrible, terrible parachute that sometimes is not even flyable or landable. And sometimes, if it's a really good parachute, no problem. If it's a really bad parachute, no problem. It's those parachutes that seem pretty good, and all of a sudden you hear this, whoa, what was that? And by this time you're at 3,000 feet going, what was that? And then you start getting, the head starts going, and those are the ones that are difficult. Do I land it or do I not? One of the other mindset things, let's go there. Blind faith in theory and science. That's one of the easiest ways to get trapped into a faulty mindset, one that you can't grow and discover new things. We're not looking to discover the known. We're trying to figure out the unknown. So you kind of have to, how do I put it? You kind of have to embrace the cluelessness that you might have and the cluelessness that you're clueless. It's hard to do when you see yourself as an expert, but that's pretty much what you have to do. And then what I call the limitations of the terminology we use. Other ways I say it is buzzwords, word salad. Fancy terms we use to describe our stuff. The easiest example of that is a misconception of like planform designs. I put this in a different seminar, I'll just pop it in here. This is a Sabre 2 planform in terms of if you look at the top, it's just a simple line drawing. And that is considered by most people a semi-elliptical canopy, and most people have an idea of semi-elliptical being a canopy that's, not a student canopy necessarily, but good for novices, all round, blah, blah. If you want to have high performance, you really need to get past a semi-elliptical parachute and jump something that has more power and more punch, and to do that, you've got to have at least a fully elliptical canopy, if not a cross-brace canopy, like a Velocity. So here's the Velocity planform. Now we consider fully elliptical, right? So it goes fast, turns fast, dives fast, slows down well. It's completely different canopy, right? Most people, not most, but many people will think it is because of the planform and the cross-bracing that makes it that way. This is the two on top of one another. Now I ask you, is there really something dramatically different about that shape that would cause you to call one semi-elliptical and one fully elliptical? And some people who are test jumpers will dismiss our expectations of designers of a parachute simply because of what it has been called by somebody or what they call it. Now obviously the Velocity and the Sabre 2 do fly very different, and since the planform actually looks so similar, it must be other things that contribute to it, and of course one of them is the cross braces, but even those don't do what people think. There's a lot of other things that cross braces do to contribute to the way a parachute flies or doesn't fly. The point is that those other things are not easy to see, and it's very easy to get caught up in not seeing what's happening with a new prototype simply because of your belief systems about these things. So when we test at PD, we have something we call the prime directive. Any Trekkies here, Star Trek fans? The prime directive is really important to me. If you ever have a chance to test jump for our company, you will know what the prime directive is, and you know that there is no written warning if you violate it. The moment I see somebody violate this, they are done forever. I don't care if they're world champions and God's gift to skydiving, they are done. So here it is. First off, you must have, this is pretty basic, you must have a main canopy that you can cut away, and you have a reasonable expectation that it's going to work well enough to land, a reasonable one. Doesn't mean you're absolutely sure it's going to work, but you're pretty sure it's going to work. Second part is you must have a real reserve, TSO'd, properly functioning reserve in a reserve container, and you cannot have a way to cut that away. You might think that's funny, but we do have rigs that carry multiple parachutes, and we can cut away any parachute. The third thing is that any other parachutes you need for the particular test, like an intentional cutaway, all of the parachutes you plan on using have to be something you can cut away, and the parachute that you are carrying as your real reserve cannot be something you cut away. Now that, again, might sound pretty simple, but in the typical 3-parachute rig, we can rig it so that any parachute can be the first, second, or third parachute. So you have to choose the container that will be where the real reserve is, okay? So that's the first part of the prime directive. I have had somebody violate that. They were doing 3 parachute jumps where the top and bottom parachutes were both something that could be cut away for a TSO test involving a cutaway, and they had a chest mount that could not be cut away. And then they needed to do test jumps on 1 parachute without a cutaway. They put the reserve away and then jumped the rig where both the canopies on the back could be cut away. That violates this. And when I saw it, he said, oh, I know which handles I'm pulling. I can't live with that. So he no longer, the day I saw that, he never jumped for us again. So that's the first part of the prime directive. There is a second part. All of our test jumpers may refuse to make any jump for any reason at any time. The test jumper has to be in control of that. Now, we might say we're not going to let you jump it, but if we do say you're going to jump this thing, that you can jump it, it's up to them if they really want to. And the reason is because they have to perform well, and if there's too much fear or concern about it, they're not going to perform well. Now, we say no questions asked, but we usually want to discuss it because we're wondering if there's something we missed. And it might be that they're spooked with the winds or they have a hangover and they shouldn't when they're jumping, and it's a good decision. I don't want anybody to fear for their job because of that. So now I'm going to show you some examples. Anybody have the time? I just want to know. We did start late. I want to make sure I get through this. 20 to 3. Okay, I'm going to try to roll. We were asked to do a cargo system, guided cargo that would carry 1,100 pounds and do it with very few prototypes. And we built a parachute, 800 square footer, and then this guy gets on the phone and says, tell me the control stroke required to provide a turn of X number of seconds, X number of degrees per second. And I went, I don't know. And they said, well, we need to know because we don't have much room to pull the control lines down. So we had to find a way. This is the way. This is a deployment flight test, June of 2000, 720 pounds exit weight. Can you play the video? So we did a triple tandem. Being the real company man, I'm the guy in the middle. It was really uncomfortable. So it's a static line, Scott Miller on the back. Opening was very quick because static line, single back static lines are not a real good way to deploy a parachute, especially that big. The front person had his own rig, and we cut him away. We cut him away so that he could deploy his own parachute, so we were meeting the prime directive. We then realized we needed the front jumper to have a jumpsuit on so that we'd be more stable because the relative wind is going along our backside. We got our turn rate discussions. It was a little difficult to control the parachute because we were talking about every turn, like, you know. It was like 3 people to discuss it, like 3 people discussing the spot. I guess you guys spot by GPS now. Here's the landing. You get an idea of the size of it. This is with 2 people under it. If you watch how long it takes the parachute to hit the ground, I was really impressed with Scott's ability to land accurately there. Watch how long the parachute takes to hit the ground. We're on the ground now. The first time we suited up to do a practice exit, we were in the shop, and we said, well, where are we going? Well, let's just go to the hallway. And we all stepped over there and nearly fell on ourselves. It's like a triple three-legged race. Okay, so one example of unusual testing, we did well on that, and that became an actual system that worked. Are you going to move? Okay. So that became a system that actually was used in theater, and on, I think it was 4th of July, they didn't quite conceive of what this thing could do. They actually delivered for the American Independence Day hot dogs and Coke. Hot dogs hot, Coke on ice, and like they were kind of tired of being out in the desert. So this one is the dual square thing. The problem early on when I was jumping is that if anybody had an automatic activation device, as we call it, on their rig, and you were an experienced jumper, many people would not jump with you because they were very unreliable. Nowadays, people won't jump with you unless you have one, but it wasn't like that back then. And there were people having 2 canopies out because they were pulling low. And in the early days, it was mostly around parachutes, but when the 2 ram airs came out, people wanted to know how well they coexisted. And there was a couple studies, but we decided to really go hard on it because people were having weird things happening. So we wanted to know, could we actually test for that, and what would we test? And the thing that bothered me is there was a lot of canopies coming out at the same time. Right when your body sits up, there's a pressure change, and then the reserve would come out as the main was coming out. And I thought at some point that's going to catch up with somebody, and so we wanted to test it. And a lot of folks said we were nuts, and we wondered if we were. But we decided to look at that because we felt it was our responsibility to do so. And we wanted to know any other extremes. We wanted to do big main, small reserve, small main, big reserve, pulling them in all different orders, all that stuff. So we wanted to do it, but we didn't want to make it just a PD thing, so we got other manufacturers involved, other parachute manufacturers, container manufacturers, and we convinced PIA that it was worth it. They had a few concerns, but we said we would pay for it, so, we would do it. We got $5,000. I think we spent 3 times that much, but we said we'd do all the testing. So we tried every combination, main, big and small, all big, both sequences, simultaneous deployments of reserve and main. That required a rig to meet the prime directive, 4 parachutes. And I made quite a few of those jumps. I don't quite remember where the handles were. It was a long time ago, but I remember practicing in the airplane before exit, and every time the whole load just roared with laughter, as I'm going through all these handles. Anything that we came up with along the way, we'd give a try. So I want to show a couple videos. This is, can you turn the volume down? Thanks. This is reserve out with the main at full glide, and the biplane, no biggie. We flew it around, see how it did. This is the reserve out, and then the main second. I thought it's going to be the same thing. It didn't pull the pin, so I gave it some help. And the canopy went to the end of the lines, and I thought, oh, okay, another biplane. Yeah, here it comes, another biplane. Oh. So that was my first downplane. I couldn't share with anybody, though. And I cut away the main. I could also cut away the reserve because I had a 3 parachute system. Is that the end of that one? So this is not a dual square seminar. But I just wanted to show a few things. We had lots of instructors that were saying, if you had 2 canopies out, cut the main away. Like, why not? Why wouldn't you? Well, usually the main is in the front, not always, but usually, like it is here. The main is white, the reserve is the multicolor stuff. So we decided, well, what would happen? So, oh, it doesn't look good, does it? So every single time we cut the main canopy away when it was in front, it stops flying, and then your reserve goes flying through the lines and the risers. This one doesn't look good, does it? So perhaps this is a good time to talk about our employee retention program. He did have a 3rd parachute. The prime directive required that, and he was one of the very few people who got to the third parachute. It was a round parachute in this case. We were running out of stuff to put in things, and the jumper felt more comfortable with a round on the front than a square, this particular jumper, and he ended up using it. Again, the prime directive, I'm not jumping it unless it's a round. Okay, put a round up there. Obviously, cutting away the front parachute in a biplane can lead to situations that we could take care of, but you guys would not be able to with your equipment. How about flaring? People were saying flare the main, flare the reserve, flare both, don't flare anything. That's flaring the main. And did you see what the reserve did? Kind of weird. So we found that when we flared, it didn't do anything good, and sometimes it hurt. That's not flaring at all. This is when I don't remember who that is, but we flare and it doesn't help at all. I mean, there's no difference basically. So we say small inputs and then just land it with, look at that one. Again, the parachute behind, even side-by-sides definitely do not flare if you're gonna land a side-by-side. And certainly do not flare just the outside or just the inside toggles. We don't wanna get into why, but the inside toggles is even scarier than the outside ones. So again, this isn't a dual square thing, but I thought since we're talking about crazy stuff, I'd show you some simultaneous deployments. I think this is me. And I kept noticing that the main got to the end of the lines quicker than the reserve because of the burble of the pilot chute. So there goes the main, and there goes the reserve, and look where it's going. But what was really strange is that they sorted themselves out. I was kind of like, darn. I want something really scary to happen, you know? Make me feel alive. Here's another one that had a lot more burble. And I was really, really amazed at how well the two parachutes coexisted when they were both attached to you, unlike when you cut one of them away. So we started delaying the release of the main to try to get them both up there because we really wanted to have them get entangled, and it got really wild. I was amazed at how well they coexisted together, and it gave me a lot more faith in the idea of automatic openers. This one's pretty interesting. Really trying to get them out at the same time, and oh, there we go, that looks good. It was shocking to me. I thought we'd be going to number 3 parachute at least. There's one that's really interesting, and I'm almost glad I didn't know what was going on behind me. I think this is the next one. It might be the one after this. Sorry for the quality of the video, it is old. So these are 4 parachute rigs. There goes the reserve. Here goes the main. Watch where it goes. Oh, this doesn't look good. And look where it goes afterwards. It comes right back out. I didn't find the video when I was looking for this, but I had one where the pilot, she was going straight for the main the reserve slider, and just the last frame, it went whoop. It was really amazing. So surprising. Now we did have a couple that went bad. One of them, the one parachute hit the slider of the other in its bag, and then it dropped down, and the jumper went poop. What do I do with this? And he just went, well, the parachute's flying. I got 2 more left, but why bother? And he stuck it between his legs and then flew. And at that time, there was this technique that people used to do on their approach. When they'd pull their front riser, they'd go, and he let it go. And it tumbled into lines, opened into a downplane. And he was injured. That was sad. We learned to not let go of it if we're going to do that. Another weird one. This is a satellite recovery system that we were doing for this really interesting, I don't know, strange engineer guy. And what they wanted to do was they wanted to recover the satellite differently. What they would do is they'd come into the atmosphere at an angle, and if it was a little higher or a little lower, it would go this way or that way 50 miles, and then it would drift around in a round parachute, land in the water, and then they'd traipse around in a very expensive vessel looking for it, and it was expensive, and then the thing was clogged with water. It was very expensive and time-consuming. They wanted a ram air parachute because they wanted to mid-air retrieve it, and if they used a round parachute, if they flew over it with a helicopter, it would collapse the round. So if it was flying forward, they were hoping that that wouldn't happen. But they wanted proof that it would work and that the satellite recovery parachute would actually collapse. So they designed what we used to call the canopy erotica. It has two things sticking out the top, two of them, you'll see. So this is, I'm the guy catching the canopy. Scott Miller is the video, and this is Jimmy Traynor, an excellent test jumper. There's the canopy. Here goes me. And the canopy was set up to fly descend as slowly as possible with a small pack volume. And it was not flareable. It was set up creeping along, and if you pulled the toggles down, it would just stall. So I'm trying to get into place. Can you see the little things sticking out of the canopy? They're like two little inflatable penises, kind of, with a line across. And I'm hooking it with my feet, acting like I'm a hook on a helicopter. And that proved to the helicopter pilot, maybe this will work. And then we let him go. And it reinflated, and then later he cut away, which you'll see here in a second. That's about a 80 square foot F-111 canopy with no flare, so we don't want to land it. And so you can see the little horny thing sticking out. And so he cuts away and goes back to his main parachute, and then he's got his emergency reserve that he cannot cut away. This looks a little scary. Cameraman is trying his best to get the shot. Oh, there he is. Stiletto 97. So I'll show you another view of this if we have time. This is my view from my helmet camera, very vintage old one. So he's deploying the main out of the chest mount, and it's got a double-handled cutaway system. And then I leave, that's my weird camera. I'm not that good with crew, so it was interesting to do, especially that particular parachute was chosen for its quick opening characteristics, not its soft front riser pressure. And you know, sometimes you try to stay in the moment. Sometimes a thought pops in your head, and when I get behind this thing and I see that line across there, suddenly I felt like an aircraft carrier pilot trying to hit the wire. It was really, really a neat feeling. I'm like, look at this thing, it's coming right at me. That was a really neat feeling. The line, you can just see it there. Boom. And now I put my feet together, keep the toes up, and then after a little while, he starts turning a little sideways, and I point my toes and let him go. Booties on, just because I didn't want it to catch on my shoes. And then the next view is of the test jumper on the test canopy. This is his leg camera. Now, this is before all this GoPro stuff. We have a mirror, a convex mirror that you put on a truck to see, you know, a lot behind you. That's put on his foot on a piece of metal, and there's an altimeter there that shows his altimeter. So the camera is looking down at the mirror, and you're seeing the edge of the mirror there. Yeah, it was pretty low tech, but that's all we had back then. So in just a second, you'll see me cruise by the top of it. I'm trying to get down to him. We don't do much of this kind of stuff, but it's fun, and I thought I'd share it with you. So I'm coming across here in just a sec. And, oh, there it goes. And then I drop him. And they actually did use this for recovering a satellite. And eventually, the helicopter pilots and some other companies were so enthusiastic about this way of doing it that they found a much easier way to grab the parachute. They just grab it by the bridle now that they know it's going to collapse eventually. And as you can see, the reserve opening from his view doesn't look like it took quite as long. All right, we'll move on. This is a typical cutaway for an intentional reserve deployment to meet TSO tests. And I want you to realize it's not just getting the parachute to meet the TSO. The bulk of our testing is to get a parachute that opens, flies, and lands the way we want. And at a certain point, we have to test it to make sure it meets these standards. So he's hooked up backwards right now. And the test parachute is on his chest. That was a 99 on a simultaneous cutaway and reserve ripcord pull. You got to be good at flying a parachute backwards, but you don't have to be good at landing it, which is kind of nice. Unless somebody packed a chest mount wrong. It actually looks wrong when you put it in the container because the container is around the front, but the parachute's supposed to face the same way. So when you put it in the chest mount, it looks backwards. So we also did, again, in the idea of weird stuff, we did deployments. We did some tests on a parachute that was supposed to be an ejection seat parachute that was a ram air. This was after the guy got shot down and he was drifting towards the enemy, and the enemy was in trucks following, and when he landed, he was greeted, and they just wanted something that would glide. So they wanted it to be deployable at 300 knots, and they wanted it to be something that could be deployed at no airspeed and open from the ground, shooting them up, which we thought would be about 120 feet. So we had to design a deployment system that at 300 knots wouldn't kill you, and at 120 feet with no airspeed, it would open. So we did a lot of crane drops with a very interesting speed sensing deployment system. It was crazy. We spent all the money that they gave us to do this. But this is one of the high-speed drops on one of the parachutes. This does not go well. 280 knots is about 320 miles an hour. This is a 335-foot canopy that is about the shape of a 7-cell, but this one has 9 cells. And basically, when you can turn the volume up on this one, great old B-25 bomber, going as fast as it will go. And you'll see everything comes apart. There's the weight, deployment device, and the whole rear riser group came off. And it flew on front risers. There's no C, D, and control lines attached to the parachute. You'll get an interesting landing with 340 pounds, with not even no brake set, but basically full front risers. So this is one where the pilot was confident he can go another 5 knots without the airplane coming apart. So that's about 328 miles an hour. This is a 7-cell. And this was a really good opening, less than 3 Gs, which is like a typical opening. Everything worked properly, our deployment system. It was actually a brake release to make it turn that caused the previous failure. And that was a pretty amazing opening for a parachute that can open from 120 feet drop from a crane. So again, more weird stuff. So now let's go on to something more mundane, a typical day at work, so it looks. This is one of the prototypes of the Peregrine. It's a very small one, and we were liking the way it flew, and we decided to go to high altitude to test it. And this is our test jumper without any concern, just releasing the brakes. And now he's going to land a 61 square foot parachute at a 6,000 foot field elevation, or maybe decide not to. This stuff is weird, you know, and that's why we go to 6,000 feet to jump these things, and that's why that parachute did not go on the market that way. We learn all the time, and we only learn because we entertain that there's something we're missing. Okay? This makes me very concerned, by the way, about riggers and shops that make aftermarket line sets for high-performance parachutes with the idea that it'll fly better or open better. I will not make a line set for anything that we didn't design because I don't know enough about somebody else's parachute to be messing with that. And I don't think anybody should do that, really. This is a typical prototype test. This is a few years old, but it's something we're still working on. It's a bigger canopy that's semi-cross braced, meaning just in the center. I played this here a few years ago, and it's kind of interesting because it's not that bad, but it doesn't meet our standards, and you'll see some things that don't make sense. It seems to be stable on front risers, but it's got really high riser pressure. This guy's really working. And then on toggle turns, you'll see the tail fluttering on the opposite side. We've since, see that? We've since done many more prototypes on this parachute. We're really excited about where it's going. There's a few things we'd like to continue with, and we're going to continue. There is a desire to have it done, but there's no timeline to make it complete. It's complete when it's complete, as frustrating as that can be. They're amazing on the rear risers, which is really cool. I'll move on. So in the old days, people did that, and nowadays, it's changed to this. Now, there's some common things here. You don't see a slider on either one of those parachutes. And the reason is because the guy with the Kestrel on the left side of the screen, he's sitting on a slider. You had to get creative to have fun in those days. And this one, of course, has got the removable. So it's changed a lot. So the link between the way a parachute flies and the designer's intentions is all about the test jumper and the collaboration between the test jumper and the designer. But the third thing I mentioned, that is you guys. Because once we pronounce it to be finished and we put it out, you guys jump them and get very creative with it. And sometimes you guys are able to do things with the parachute that we never anticipated. Sometimes that's not a good thing, but very often it relates to new things and better performance. And it also enables us to see the growth in the sport such that we're now willing to make parachutes to do even more interesting things, more performance, because we can see there's a market for it that we can safely enter. So basically, we've tried to make better performing mains and reserves in a wide variety of sizes, better openings and landings. We brought out cross-brace technology, and also developing and sharing better techniques for flying the parachutes and landing them. And that's, again, where you guys come in, because you surprise us. Some of the things that are being done now with parachutes just amaze me. So that's it. I have no idea how late I am, but I did start late. Thank you very much. Oh, so it is 3 o'clock. I actually saved the time that I lost at the beginning. If you like, you can meet me outside if you have any questions for me, okay? And thank you very much for your contribution to the whole thing. It's a collaboration of all of us.